Hello everyone, welcome to Trig Inverses Day 2. We are going to be doing some solving today. Also, I haven't looked at this app in a week. Let's see if I remember how to use it. Here's some hope. Okay, let's see. We're going to have solving day 2. After the solving, we'll spend some time going to evaluating, and then it is in fact test day. So the first problem that I have for you today is a doozy. So our first example problem for today is in fact 2, let's see, sine squared of x plus sine of x minus 1 is equal to 0. So taking a look at this, if we were just dealing with something with x, this would be like 2x squared plus x minus 1. Now there's a few different ways that you can solve for this. You can solve for this either by factoring. You can use the Box-Diamond method. You can also just use the quadratic formula. You are allowed to use that. So I'm going to split this up into two different sections, not solving for different solutions, but just showing you different ways of doing this. So are we going to do this twice? Absolutely, of course we are. Let's get down to it. So the first way we're going to do this is we're going to do this by factoring. Ooh, I forgot how bright that green was. Okay, so when we do this by factoring, let's go back to black. Come on, there we go. Let's go back to black. Let's see, we have to break this into two separate groups. You can either do this with a table, you can do this with a diamond. I'm going to do this with a diamond off to the side. We want our a value times our c value times, and then our b value. So our a times our c value is going to be -2, and our b value here is 1. So let's see, it has to multiply to our a times our c and add to whatever our b value is. So if we're looking for two numbers that multiply to -2 and add to 1, that is going to give us 2 and -1. So now, I'm really wishing I had done that side work in a different color, but who cares? So now what our equation is going to look like is 2 times sine squared x plus 2 sine of x, and then you're going to see what I'm doing in a second, plus a negative sine of x minus 1 is equal to 0. And the reason I'm doing like the plus the negative sine of x is because when you are doing factoring by grouping, you need to have, oops, how do we erase that? Can we just do like an undo? Nope, okay. I found the undo button, yay, okay, I'm not editing that out. That's just gonna be as it is. Anyway, so when you are factoring by grouping, you need to have two pieces here that are being added together. So if you are using factoring by grouping and you have a negative number, for instance, this negative sine of x, please make sure you do put a plus sign in front of that. So now we need to factor things out from each group. So let's see, this will be 2 sine of x times sine of x plus 1 plus, and then if we need to see, hey, what can I factor out of my other factor to make it look like my previous one, I'm going to factor out a -1. So we get sine of x plus 1 is equal to 0. And I know I've done this correctly because in my parentheses I have sine of x plus 1 both times. But now I'm going to take my two factors and bring them together. So that's going to bring me to 2 sine of x minus 1 times sine of x plus 1 is equal to 0. Yay! So we're not nearly done with the problem. We still have to do all the trig stuff. I will go back and do the quadratic formula in just a little bit. Oops, I'm so sorry. I'm still trying to figure this out. So let's see, once we are here, I'm going to take this and I am going to, let's use the yellow, split this up. It's a very mustard yellow. I'm going to split this up into two different problems. I'm going to bring it away. So it's going to be 2 sine of x minus 1 is equal to 0, as well as sine of x plus 1 is equal to 0. So I'm just going to go through, solve these. Let's see, on my left side, I'm going to add 1 to both sides. Divide both sides by 2. I have to get x by itself, so I need to sine inverse both sides. So I get x is equal to sine inverse of 1/2, or at what value, pardon me, at what angle is the y value 1/2? And for us, that is going to give that x is equal to pi over 6 and 5 pi over 6. So that's going to be our left side. On our right side, much faster, we're just going in case you're wondering why I was cut off mid-sentence and then was silent for a while, it's because I figured out where the mute button is and accidentally pressed it with my hand. I'm so sorry. I have no idea where I am in the problem, but taking a look at this, looks like we finished. If you have any questions, please email me, but hopefully those last 3 steps were fine. But if you're looking at this and you're like, Miss Twain, those first 3 steps, it's a no-go for me. Let's do this whole thing again, but using the quadratic formula, because why not? We love a quadratic formula. So I'm going to move this whole thing up. We're going to use our green again, our very, very bright green, and do quadratic formula. And for those of you who cannot remember the quadratic formula, I'm going to sing it to you right now in a very monotone voice. Feel free to skip the next, I don't know, 10 seconds. If you don't want to hear me sing, I will forgive you. All right, so the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Yay! There's a lot of YouTube videos that exist in the world if you want to see that a little bit better. But what I'm going to do is I'm just going to rewrite the problem down. We're going to go through this really quick and get this started. So just a reminder, the problem was 2 sine squared x plus sine of x minus 1 is equal to 0. Quadratic formula, you know you love it. You got a is equal to 2, b is equal to 1, and c is equal to negative 1. Let's plug this into our formula. And I am going to move this up just slightly, and we should be getting the same answers in the end. So let's see. We got x is equal to negative 1 plus or minus the square root of 1 squared minus 4 times 2 times negative 1 all over 2 times 2. That was a mistake, I'm sorry. 2. Yay! Okay, so let's see if we simplify this down. And if you're wondering when I said yay, yes, I did throw my arms up in the air. So let's see, this becomes negative 1 plus or minus 1 minus a negative. I got a, let's see, I got a negative here and I got a negative here, so those are going to become positive. Plus, it looks like to be the number 8 all over 4. So this becomes negative 1 plus or minus square root of 9 over 4. Square root of 9, also fun fact, known as the number 3. So this is going to be x is equal to negative 1 plus or minus 3 over 4. And what this gives us is x is equal to 1/2 and x is equal to negative 1. But here's the tricky thing here. This is not x in terms of like our x. So what this really is, and we go back and do this in blue, this is sine of x for all of these, because that's what we're really solving for. We're not just solving for x by itself, we're solving for this function. Ooh, I did not leave myself enough space over here. Brr. All right, so what we're gonna do, let's split this up into our 2 separate problems. Move this up again, get that into the black. There we go. So what we really have is sine of x is equal to 1/2, and sine of x is equal to -1. We should already know the answers to these. Again, this was our positive answer. This was our negative answer. This is the exact same thing that we had in our previous problem, so make sure, again, you put it in your solution set. You get pi over 6, 5 pi over 6, and 3 pi over 2. Woo! Okay, 10 minutes. We did the same problem twice. Let me know if you have any questions. So at this time, we are getting into material that it is definitely good to know. However, due to the shenanigans that are currently happening in our world, we will not be testing you on it. I met with Miss Ray and Mr. Brown, and we looked through all the things that we were like, what can we cut? So for the next 3 examples, those will be what we are cutting. But feel free to stick around if you plan on continuing your math career, just because it may be useful information, and or if you're super bored, feel free to stick around. All right, so let's see, I'm gonna move all this. We do have 3 more examples. One of them's kind of long, the other 2, not so much. So let's try this. We're gonna move this over here. All right, so let's see, for example number 2, we're gonna have tangent squared x plus 2 tangent of x minus 2 is equal to 0. This is something I can't think of any numbers that multiply to -2 and add to 2. So we're going to use quadratic formula again. I love it. It is up above if you need to go back and look at that. But let's see, that is going to be tangent of x, so not just x, is equal to negative our b value plus or minus square root of our b value squared minus 4 times our a value times our c value all over 2 times our a value. So let's see where this gets us. All right, so we got -2 plus or minus the square root of 4 plus 8 over 2, which means that tangent of x is going to give us -2 plus or minus the square root of 12 over 2. And then from here, you can do some side work. I will do little bit of side work and say that, hey, square root of 12, that's the same thing as square root of 4 times square root of 3. And square root of 4, that's just 2. So that's really going to be the same as 2 times the square root of 3. So let's bring that back into the problem. And that's going to give us that tangent of x is equal to -2 plus or minus 2 root 3 over 2. Why was that important? The 2's cancel out. Yay, we love that. So when that happens, again, yes, was pumping my hands up in the air. When we do that, we get tangent of x is equal to -1 plus or minus square root of 3. So when we take a look at this and we go, hey, where is that on the unit circle? You may be like, Miss Twain, I've seen a -1, I've seen a square root of 3, I've never seen these together. What do I do? Well, we are about to live in the realm of decimals. This is something you will start by plugging into your calculator to get first quadrant answers, but that's all the calculator will give you, is just the answers for the first quadrant, not all of the answers. So we're going to have to draw some pictures. So if we have our 2 answers here of tangent of x is equal to -1 plus square root of 3, and tangent of x is equal to -1 minus square root of 3, and we apply tangent inverse to both of those, we get x is equal to tangent inverse of -1 plus the square root of 3, and x is equal to tangent inverse of -1 minus the square root of 3. So we get to here, and you're like, Ms. Twain, we can only have one of the answers. What you're going to find is you're going to find the positive answer for, sorry, not positive. All these answers should be positive. They should be between 0 and 2 pi. You're going to find the first and or second quadrant answer for each of these. And then go around. I know we just said first quadrant, but it gives us, I meant the first hemisphere? Hemisphere, yes, the first half of the circle. So what that's going to give us is if I take, I'm going to use my positive version here, -1 plus square root of 3, and I plug that into the calculator, I get about 0.63. So if I was to draw a unit circle off to the side, which I am about to do, that's a really poor looking circle. That is okay. So we're going to draw ourselves a unit circle over here. Over here is going to be 0. Now in this top 90-degree section right here, I'm not going to write pi over 2. I'm going to write 1.75 because that is the approximation. Instead of writing pi, I'm going to put 3.14. So I'm going to set it up in decimals. So if I was to look to see where tangent of -1 plus square root of 3 is, it's going to be about 0.63, which is like here-ish. That's like right there. So that's 0.63. Now here's the thing. If I want to find the other answer to this, remember tangent is sine over cosine, or your x value over your y value. So in this case, if we're getting something here, where my x and y are positive, positive over positive has to be positive. The other place where that happens is where it's a, ooh, this is not the correct, that is drawing right here. That's also going to happen here, where it's a negative over negative. That's going to give us the same answer. But how do we get that? Well, that should, despite what my drawing looks like, be exactly half of a circle, or pi, all the way around. So what I'm going to do is I'm going to take my 0.63, I'm going to add pi to that, and I'm going to get that my other answer is, let me look at my notes, 3.77. So those are the answers you're going to be getting. First one you plug into your calculator just like normal. Second one, in this case, tangent is across the unit circle, or in this case, pi. So taking a look at our other option, if I do tangent inverse of -1 minus the square root of 3 into my calculator, which should be set to radians. Sorry, I should have said that. Should be set to radians. When I plug that into my calculator, I get about, what do I get? 1.92. But again, that only gives me one answer. So 1.92, that's pretty close to 1.75, but it's definitely in our second quadrant. So we're going to say that's like, I don't know, here-ish, guesstimate. But if that's where that answer is, I still need to go across my unit circle to get that answer. Very good approximation. Okay, so about right here. So from this answer, that's my second one, I'm going to take that and again add pi. So my second answer for this one is going to be 5.06. So there we go. So if I'm looking for my answers here when I'm dealing with tangent with something that's like not actually on the unit circle, I am going to, so let's do this one in yellow. I'm going to take whatever first answer I got, and then I'm either going to add or subtract pi to that, just because it's half of a circle. If you go the other way, you should get the same answer, or you can find the coterminal angle, which is what you'd be finding. So here are 4 answers. Right now, feel free to take a moment and pause, let this sink in. Again, this will not be on our unit test. However, it might be a good idea for you to know this just for your future math careers. And I think now is a good time to get our second, I forget what I call it, keyword, special phrase, password of the day. So for our next week, so not the 13th through the 17th, but the week after, if you come to class, I want you to greet me with the word Squidward. Your keyword of the week, or your password, whatever we're going to call it, is Squidward. You're welcome. Okay. 2 more examples, not as intense as this, but definitely not great. Anyway, let's move on. We're going to move this up here. So for our third example, We're just going to make the algebra on this way, way easier. We're just going to say that sine of x is equal to 0.9. Ta-da! If I were to take a look at this and go, okay, solve, I'm going to use sine inverse on both sides, and I get x is equal to sine inverse of 0.9. Cool. I plug that into my calculator, and I get that x is about 1.12. We're still not done though, because that is one of the answers. You will always be able to get one of the answers by plugging it into your calculator. The trick is finding the other answer. So let's take a moment, let's draw ourselves a unit circle, because that's going to be really helpful. Oh, way better circle. Actually, maybe not. I can't quite tell. All right, so we're here. I'm going to redraw the circle we had up above. Ooh, not good. Let's see, there's 0. This is 1.57. Just a reminder, that's about pi over 2. We got 3.14 over here. Now what we just found is the answer of 1.12, which is, let's say here-ish. Right there. So this is 1.12, and we just found our angle, just red. We just found our angle right here. So that's our angle we just found, that's the 1.12. Now, here's the thing about sine. Sine is our y value. So I need to find some other spot with the same y value as this point. So what I'm going to do is I'm going to go across my circle. I'm going to say, hey, this spot right here, that has the same y value, right? So I'm looking for whatever this angle is right here. Now, honestly, I don't know what that angle is, but I do know what that angle is, because it is the same as our previous answer that we just found. It's the 1.12. But instead of starting at 0 and adding it, we're starting at 3.14 or pi, and we need to subtract it. Remember, we're going clockwise around the unit circle, which means we're going negative. So when I want to find my second answer, what I will do is I'm going to say, hey, my other answer, we're going to have x is equal to, starting at pi, and then subtract whatever our first answer was. So we're going to subtract sine inverse, ooh, this is close to the unit circle, sorry. Sine inverse of 0.19, which we have already found. It's going to be about pi minus 1.12, or about 2.02, which is going to give us roughly this spot right there. So again, our answers are 1.12 and 2.02. So whenever we are finding something, particularly for sine, when I want to find my second answer, I'm going to say, hey, pi, what are you doing? And then I'm going to subtract x, or whatever our value was from that. Let that sink in. So this is what we will be doing for sine. Thank you for sticking with me. We've got one more example. You may have guessed it. It's cosine. Okay, so our very last example is going to be cosine of x is equal to 0.25. Again, not something we recognize from our unit circle. We know pi over 4, or 1/2, but we don't know this number here. So when I do cosine inverse to both sides, we get x is equal to cosine inverse of 0.25. I'm going to plug that in my calculator. I get x is about 1.32. Cool. Awesome. What does that mean? Let's draw a unit circle. So let's see if I go like this. That's evenish. Let's see. 0, 1.57, 3.14. Okay, so let's see. 1.32, it's about here-ish, maybe? Again, these are all just approximations. Thank you for your patience. I need to find something with that same x value since we are dealing with cosine. So since cosine is x value, I need to go all the way across my unit circle this way. So making sure I have the same x value, and that's going to land me about here. So I'll do that in blue. It's going to land me about here. So now I need to find the angle for this one. Well, I know that this angle here, we'll pretend that's even. This angle here, the one we found, is the 1.32. So now what I'm going to do is I'm going to start here and go backwards with that exact same amount, giving me the full angle. But instead of doing 0 minus that, we're going to say that this is 2 pi, and then subtract from there so that we get a positive answer, because we are looking for positive answers between 0 and 2 pi. I do not want any negative answers here. So what we're going to do is we're going to say, hey, this is really x is equal to 2 pi, our whole circle, minus whatever our previous answer was. So in this case, it's cosine inverse of 0.25, or you can look at that approximate, 2 pi minus 1.32, or about 4.97. So you should be getting the answers of 1.32, that's from your calculator, and with a little extra work, you get the answer of 4.97. So in the examples of cosine, we're going to start with 2 pi and subtract whatever our first answer was, so we can get our second answer. Now, if you're looking at this and you're like, Miss Twain, this is too much, I'm never going to remember all of this, we're going to write this all down right now just for us. All right, so important information. For tangent or cotangent, because those are fair game, I want you to take whatever value you have and then add or subtract pi depending on where your first answer is. So this is what you're going to have for tangent and cotangent. For sine or cosecant, we're going to take a look at pi and we're going to subtract our first answer from there so that we can have the same y value for both of those. And then for cosine and secant, we're going to take 2 pi and subtract the angle that we have because they're both supposed to be x values. So right here is the big ta-da from the last 3 examples. Please message me or join our Zoom class if you have any questions. Thank you for sticking out this long. Hope you enjoy the next video.